Delving into sklearn's BaggingRegressor, a comprehensive guide. BaggingRegressor in scikit-learn is a powerful ensemble learning technique for regression problems. Let's break down its inner workings, advantages, and practical applications. 1. Foundation bagging and bootstrap aggregating. Bagging stands for bootstrap aggregating, a key concept in ensemble learning. The fundamental idea is to build multiple independent models estimators on different subsets of the training data. Bootstrap aggregation refers to the process of creating these subsets. Randomly sample with replacement bootstrap from the original training set. Each bootstrap sample will have the same size as the original dataset. But some data points might be repeated while others are excluded. These bootstrap samples are then used to train individual estimators, effectively creating a diverse collection of models. 2. BaggingRegressor in sklearn. The BaggingRegressor class in scikit-learn implements this bagging process for regression. It takes a base estimator as input, which is the individual model you want to use within the ensemble. Common choices include decision trees, decision tree regressor, support vector machines SVR, random forests. Random forest regressor already incorporates bagging internally. The BaggingRegressor then creates multiple copies of the base estimator and trains each one on a different bootstrap sample. It allows you to control various parameters. Nestimators, the number of base estimators to create. Max samples, the fraction of samples to use for each bootstrap sample, defaults to 1.0. Using the whole dataset. Max features, the fraction of features to use for each base estimator, defaults to 1.0. Using all features. Bootstrap, whether to use bootstrap sampling, default is true. Bootstrap features, whether to use bootstrap sampling for features, default is false. 3. Advantages of BaggingRegressor. Reduced variance by combining multiple models. Bagging helps reduce variance overfitting in the predictions. This is especially useful when the base estimator is prone to high variance, such as decision trees. Improved robustness. The ensemble is less sensitive to outliers or noisy data than individual models, as the effect of a single outlier is averaged across multiple models. Parallel processing. Since the base estimators are trained independently, bagging can take advantage of multi-core processes for faster training. 4. Applications and use cases. Regression problems. BaggingRegressor is particularly useful for complex regression tasks with high variance. Improving accuracy when applied to base estimators with good bias but high variance, e.g. decision trees. Bagging can significantly improve the model's accuracy. Handling nonlinear relationships. It can capture complex nonlinear relationships in the data effectively. Data with high dimensionality. Bagging can handle datasets with many features without significant performance degradation. 5. Example implementation. Python. From sklearn, ensemble import BaggingRegressor. From sklearn, tree import decision tree regressor. From sklearn, datasets import load Boston. From sklearn, model selection import train test split. Load the Boston housing dataset. Boston load Boston. X Boston. Data. Y Boston. Target. Split the data into training and testing sets. X train. X test. Y train. Y test train test split X. Y. Test size 0.2. Random state 42. Create a BaggingRegressor with decision tree regressor as the base estimator. Bagging model. BaggingRegressor. Base estimator decision tree regressor. Nestimators 100. Random state 42. Train the model. Bagging model. Fit X train. Y train. Make predictions on the test set. YPRED bagging model. Predictix test. Evaluate the model's performance. From sklearn, metrics import mean squared error. MSE mean squared error retest. YPRED. Printf mean squared error MSE. 6. Caveats and considerations. Computational cost. Training multiple Bayes estimators can increase computational time compared to a single model. Bias variance trade-off. While bagging reduces variance, it might increase the model's bias slightly. Interpretability. The individual models within the ensemble are often simpler than the ensemble itself, making the entire model less interpretable. Feature importance. While BaggingRegressor itself does not directly offer feature importance, the underlying Bayes estimators might. You can leverage these individual feature importance scores for insights. In summary, BaggingRegressor is a powerful tool for improving regression model performance by reducing variance and enhancing robustness. It's particularly beneficial for tasks involving high variance Bayes models, complex relationships in the data, and handling outliers. However, it's crucial to consider the computational cost, potential bias increase, and interpretability challenges associated with ensemble methods.